Okay. So group 3 is the one of my favorite subject. So just it's not about symmetries and in syllabus like that. It includes all the parts of science, from stereochemistry to um, molecular orbital theory, and many more parts of the chemistry are related with stereochemistry. So in organic reaction also, if you where to attack a reagent, if two groups are symmetric, then equal probability can attack both sides. Okay? So group 3 is not only in physical chemistry, in all the chemistry, in organic and organic also. Okay. So symmetries in nature, planetary solids. Some of the symmetries in the architecture, photography, and artwork. Okay. So the important points are, if you do a symmetry operation, the molecule should apparently unchanged, meaning it changes but look like as such. So it structure apparently unchanged. Okay, so each symmetry operation is associated with a symmetry element. Only three symmetry elements: point, line, or plane. Okay. Um, when doing the symmetry operation, the center of mass of the molecule should be unchanged. Okay, uh, so that is the center of mass. And here C2 rotation. So the rotational axis are C denoted by Cn. So the n denotes which degree you rotate. Okay, so 360 divided by n. Just put C2 means 360 divided by 2 equal to 180 degree. Okay. Okay. So these are the as I said, a symmetry operation leaves at least one point in the molecule unmoved. Okay, so that's why they called point groups. So the group theory is originally originated from mathematics. So many of the terms are related with mathematics. So you should be familiar with the terms. So only there are five symmetry operations: major identity, rotational, reflection, inversion, and improper rotational axis. ECN, sigma mirror plane, center of inversion I, and n-fold rotation. Okay, this is E. This molecule contains only the E symmetry. So if you perform other symmetry operations, cannot find anything. Okay. Okay. This is for C3 rotation. 120-degree rotation. This is big H3. So when you perform first C3 operation, the star molecule like it goes to the second stage, and when you perform the second C3, so it contains two C3. C3 power 2 means you perform the operation twice. Okay, square means just like 2 square means 2 into 2, like that. C3 square means C3 into C3. Okay, when you perform again C3, it gives the identity. So only it contains 2 C3 square. Okay, so in ammonia molecule also there are two C3. I mean C3 into C3. Okay. So you all know sigma V is a mirror plane. What are the difference between only three planes? Only sigma V, sigma D, and sigma H. Sigma V is the mirror plane which contains the principal axis. Okay, so I tell next slide what are the requirement, how to fix a principal axis. Okay, first you should understand what is the difference between three planes. Sigma V plane should contain the principal axis. Okay, and the principal axis is in the mirror plane. Okay, sigma H is perpendicular to the principal axis, and sigma D is different. It is bisect the angle between two C2. Okay, that is sigma D. Okay, This is sigma d. Okay. How to find a molecule symmetry? Okay, so in 2 marks, there also gate and basic recommend is you should identify the point group from the molecule structures. Okay, uh, so don't confuse with these terms. Okay, so uh, just first you see the molecule is linear or not. Okay, there are only two kinds of linear molecules. Let's go with the whiteboard. Okay. One is same, so two molecules are same. Okay, if like that H2, first see the linear molecule. Okay, H2. Okay, this contains an if you rotate this molecule in this axis, it is C infinity. Means you if you tan a bit small infinity amount of small degree, you also get a similar structure. Okay, so C infinity, and if you perpendicular to C2. So what is the definition of D group is Cn perpendicular to NC2. Okay, uh, if Cn axis and perpendicular to NC2, this is belong to D group, Dn group. Okay, don't forget this. It is very important. Okay, if this contains C infinity axis rotation, and if you like it's arrow. Okay, so axis of rotations are like arrow. Okay, so infinity C2s are you can draw. Okay, all C2s are okay. So C infinity and infinity C2. Okay, so that's why H2 is D infinity. Okay, D infinity, and the molecular principal axis is C infinity. And if you draw a plane perpendicular to principal axis, you will get a mirror. The two H's are replace their position, so that it contains also H plane. Okay, so it is D infinity H. Okay, linear molecule. The other is so I go with the whiteboard. Okay, so physical. Okay, um, first you see the molecule. Okay, do you understand the H2? Any doubt? So I once again explain.
No doubt, sir.
Okay, okay. I go with the second type of linear molecule, like this. The two group of different H and Cl, like that. You can also take the spleen as example. Okay. If you do the same C infinity axis, it contains the C infinity, but it does not contains the infinity C2. Okay, so if you perform a C2 rotation, the H will be replaced by chlorine, and chlorine take the place of H, so that it does not contains the C2. Okay, infinity C2, so it does not belong to the D group. Okay, so it only contains C infinity, and it also contains sigma V. Sigma V is the plane which contains the principal axis. So like that plane. If you cut the plane like this, so half hydrogen and half chlorine. Okay, so that it contains the sigma V plane. Okay, and if there is no C2, means there is no sigma D also. Okay, so it is C infinity V. So this is our two infinity groups. Okay, D infinity H, D infinity H, C infinity V. So you should identify these two molecules. Okay, not only H is here, so a linear molecule with two different sides. Okay, so they all come into the category of C infinitive. And linear molecule with two sides are same, they all come to the D infinity. Okay, this is linear molecule. Okay, um, so then you come. Then if you see a molecule, first you should saw the uh, um, principal axis. Okay, the principal axis is nothing but higher order rotation. Okay, so we first saw a rotation axis. Okay, uh, okay, NH, BH, B, okay, BH. Okay, so this contains a C3 axis. Okay, if you perpendicular to the plane, if you insert a C3 axis perpendicular to this molecular plane, you get a C3. I means 120-degree rotation. Okay, so this is the higher order rotation. Means C2 is C3 is higher order than C3, like that. Okay, C4 is higher order than C3. So you should find the higher order rotation. Okay, just seeing the molecule also you can easily find that. Okay, example, if you see a benzene like molecule, you see, okay, it is higher order rotation is C6. Okay, you can easily find by the angle between them. If you find the angle between them, just put the angle below the 360. If it is 120, means 360 divided by 120 is equal to 3. Okay, so C3 rotation, like that. If you here the angle is 60-degree. Okay, 60-degree means 60, 360 divided by 60 means 6. Okay, so that is C6. So your first step is to find the principal axis, higher order rotation. Okay, C3, C2, C4, C5, C6, like that. First you find the C3 higher order rotation, then you should find I first also said, if you group belong to D group, means it contains Cn axis perpendicular to NC2. Okay, meaning if it contains C3, it also contains perpendicular to 3C2. Okay, N is 3. Okay, 3C2. Okay, like that. If it contains a C4 and perpendicular to 4C2, means it is belong to D4 point group. Okay, so only you should differentiate between C group and D group. Okay, first you see the linear molecule. Just seeing the molecular structure also you can find the linear molecule. Okay, and cubic group like the tetrahedral and octahedral. You all very know about these structures and the icosahedron. You can easily find from structure also these groups. Okay, so the only confusion is between the C group and the D group. Okay, so that's why I again tell how to differentiate C group from D group. Okay, if you find a C group or D group, then the simple you see for sigma V, sigma D, sigma H. Okay, if it contains only sigma V, this is C2 CNV. Okay, if it contains V and D, okay, means it is CND. It contains sigma V, sigma D, or sigma H. It means CNH. Okay, means C2 plus sigma H means CNH. Okay, so these are higher order rotation, higher symmetry. Okay, so if you, higher priority. Okay, if your molecule contains only sigma H, you simply put sigma H. Okay, if your molecule contains sigma V and sigma H, so why you prefer sigma H instead of sigma V? You can also put C2 example C2. Okay, if your molecule contains C2 axis and sigma V, so we can say C2V or C2H. Okay, and then why you prefer C2H? The reason is sigma H is higher symmetry. Okay, so if you put a if you see the molecules examples, you see the molecules contain sigma H are more symmetric than the molecules contain sigma V only. Okay, So that's why they put the higher symmetry like that. Rotation also we should the higher order rotation. Okay, the molecule contains higher order rotations is more symmetric than lower order molecule, lower order rotational axis like that. The sigma v, sigma d, sigma h also the higher symmetry is sigma h. So you should give the priority to sigma h. Okay, like that. So like that, if one function is principles coming, you give the first priority to principle. If principal is not coming, you give first preference to the head of the department. If head of the department also not come to the function, you should give first preference to the professor. Just like that. Sigma h is the higher priority. So if sigma h is come, you should definitely give the sigma h. Otherwise, if sigma d comes, if sigma h is not there and sigma d only there, you should give the sigma d. Okay. This is the basic principle. Okay, just like that, C group, you just to put a D and a D sigma V, D sigma H. C. So this is the basic answer. If you understand this well, you can you can find point group for any molecules. Okay, so it does not come in one day. Okay? You should practice every day. It's like a game. Okay, so you come out of the room, see the objects around you, and just apply the symmetry elements and find the point groups. Okay, and text me which point groups in most of the things around us. Okay, in the chat box. Okay, um, mostly come to a particular symmetry element point group. Okay, so if you do this practice again and again, you can easily find simply find the molecule, and you can answer the questions in less than 1 or 2 seconds. Okay, just see the molecule. If you know the structure, you can answer these type of questions. Okay, some are you should also group theory is not only pure group theory, something mixed with other concept. Okay, so coordination complexes like that. So you should know the structure of sometimes if your question levels increases, level increases, they just give the name of the structure. Okay, so you should know the structure in 3D, then only you can identify the point group. Okay, so you see the examples. Okay. Okay. That's why. Okay. So now you can easily simplify the things. Okay, the CS and the CI and the C1 groups are simple. Okay, C1 is simply E identity only. Okay, that's it. That is C1. CI means it contains identity and I, as I mean central inverse. Okay, CS point group is it contains identity, and the identities contains all the elements contains identity. Okay, by default. Okay, CS means sigma. Okay, it contains sigma. Okay, so these are three groups, and these are the CNH, CNV. There is also a type of group S2N. Okay, so you should also know the S. Okay, I tell the what is improper rotation. Okay, then you see the DNH, DNT, DNV. Okay, some tetrahedral, octahedral, icosahedral, and C infinity V, C infinity H. Okay, so easily you should separate this only. There is a confusion. Okay, the others no, there is no confusion. SN groups I tell you later. Okay, so if you take the screenshot or share the I will share this PPT and do the symmetry. What are the symmetry element present, and find the point groups of these molecules. Okay, this is improper rotation. Okay, tell you example. This the ion complex. They give you. They asked in on Caesar or gate. Both Caesar and gate questions. This ion Fe2CO9. Okay, this is like this. The 3D structure is this. And if you see, it contains a C3, okay, so C3 rotational, and a 3 C2 perpendicular to it. Each axis is going with this the bridged carbonyl, okay. So it is belong to D3H. So it contains also H plane, okay. So the above 3 carbonyls and below 3 carbonyls are same, okay. So if you perpendicular to this is sigma H, so okay, this is D3H, okay. So it appears in many questions, that's why I take it. And one of the example is allene, okay. So these are so present in many of the questions. Okay, you should because it was just a tricky, okay. uh, Simple, the structures 3D structure is this is, and if you write a planar structure like that, okay. C4 rotation means you rotate by 90 degree, okay. 90 degree means these plane molecules go to the front and back, and these front and back hydrogen go in the plane, okay. And S4 is simple. First the definition for S is means S4 means you should first do the symmetry operation C4 and sigma, okay, perpendicular to sigma, okay. Here the axis C4 and they put the mirror plane perpendicular to this, okay. So that this molecule again, so you got the same molecular structure, okay. So that it contains S4 axis, but it also contains one C2 and two perpendicular C2, so it belongs to D2D group, okay. So I will give the examples, okay. This is the one model, okay. So you see the this center carbon is sp carbon, this is sp2 sp2, okay. So these two are trigonoplanar, the center carbon is planar, okay. Sp carbon is linear, okay. So you see the two C2s perpendicular to you. You see the two C2 perpendicular to it. Okay. So if you insert the perpendicular to the uh, this plane you got a C2 and two perpendicular C2 means it belongs to D2 group. Okay. So on the two mirror plane cut to the two C2 axis. So these are the two mirror planes. You see these, okay. Sigma 2 sigma d, okay. So it contains E1 C1 2 3 C2 2 sigma d and S4, okay. You belong to D2D group, okay. Okay. And you see this is D3D group, okay. Same like that at D2 is D3D, okay. So I told that the Cartesian coordination is very important, okay. So if you if you properly the Cartesian coordination system is very important, okay. So there is a the z axis is the higher order axis and the principal axis, okay. If several higher order rotations are there, the z axis is one part pass through the most atoms, okay. So z axis is taken like that. If you like a square planar like that, it contains two C4 axis. So the one contains pass through most of the atoms is z axis, okay. So if a non-planar molecule contains a plane which contains more than more atoms than any other plane, then is treated as the molecular plane, okay. And is you should this point is very important. The x-axis is perpendicular to the plane. If take this example, this molecule is plane, z-axis is this axis is z-axis, okay. It is a C2 axis, okay. So the molecule is in the plane, the x-axis should be perpendicular to the plane, okay, means above the plane, okay. And this means this axis is only y, okay. Sometimes they give the molecular plane is sigma v or sigma v dash, okay. But most of the time they put like that sigma x is z sigma y is z. You should know the Cartesian coordination system, otherwise you should make mistakes in the x y and rx ry rz, okay. So the coordination system is very important, okay. The rules are simple, okay. So if a molecule contain if z axis is perpendicular to the plane, the x axis is plane is in the plane. Okay, and the y-axis should be is simple. You should if you fix the two axes, the y-axis should be perpendicular to both of the axes. Okay, thumb rule like that. Okay, so you should familiar with the concept. So yeah, because you can make mistake in this concept. That's why we take time. These are the some examples and what are the symmetry elements. Okay, so easy. This is from Atkins. Okay, these structures somewhere they give structure like this and give the point group. So if you see these molecules, you can easily find the point group from that. Okay, you see this is like allene. Okay, allene is like that. One CH2 is perpendicular to the other CH2. This is staggered ethane. Okay, so you can easily find the point group from that. Okay, like that. D and K, like that. This is benzene. This is butadiene, cyclopentadiene. Okay, so like that. Okay, so butadiene. This is cyclopropene. Okay, cyclopropene, like that. So if you see this, you can find the point group by that. This is our pyramids, like the good CN group and DN group, CNB, CNH. So this is also useful for you. These some examples. So group. So I already told you that group these come from mathematics. So if you in the group, there is set of rules. Okay, so simple. The first rule is closure rule. Means if you multiply any two, if the product of any two elements, symmetry elements of the group should be also a element of this group. Okay, so if you take the C2V point group, you multiply C2 is group 3 always from right to left. You always multiply from right to left. First you should do the symmetry operation C2, then only you do the symmetry operation of sigma V x z. Okay, if you do these two symmetry option, you get the sigma y z. Okay, this is sigma V dash plane. Okay, so these also come to the point group. Okay, so the if you to take any two elements of the groups and multiply it, you get the answer. That element also should be in the group. Okay, so that is the first rule. Second rule is simple. Identity should contains identities. Okay, so if you multiply any element with identity, you get the same element. Okay, so that is the property of the identity. So and associated rule must be good. The fourth rule is every element should contains inverse element. Okay, C2 means C2 inverse. What is the difference between C2 and C2 inverse? Means C2 is always anti-clockwise. Okay, rotation about anti-clockwise. C2 inverse means clockwise rotation. Okay, so don't confuse with that. C2 means always anti-clockwise rotation. C2 inverse means just opposite, clockwise rotation. Okay. This is character table. You should know this symmetry element C3V, E2 C3 and 3 sigma V, and these are irreducible representations. Okay, and this is the order of the group point group. You should easily find the order of the point group from this. Okay, C means 1, 3 into V means 2. Okay, 2. Okay, 3 into 2 is equal to 6. So you should apply this concept to directly find the order of the group. Okay, simply C2H means 2 into H, V H, they all give the value 2. Okay, and D also contains the value of 2. Okay, so if you multiply this, D2H means D2H means D into 2 into 2. So it contains 8 symmetry elements. 8 symmetry elements. The number of symmetry elements is the order of the point group. Okay, so the number of class is equal to the number of irreducible representations. These are previous questions. Okay, so you should know that the number of class, this is the class, this is one class, this is one class. The two C3s are belong to the same class. Okay, and 3 sigma V's are belong to the same class. Okay, so 3 classes, so that 3 irreducible representation A1, A2, E. Okay, so you should be matched. Okay, and The RZ, RX, RY are rotational axis. Rx is rotation about the x-axis, Ry is rotational about y-axis, Rz is rotational about z-axis. X, Y, Z are translational. Okay, so x-axis is translation about x-axis, y means translation about y-axis, z means translate about z-axis. This is z square orbital. These are like d orbital. Like, okay, so uh, you should know all this. Okay, so the questions is based on this. Okay, and you should know the one means in the identity element the character, these are the character. Okay, so the character one means a or b. Okay, a or b. Two means e. Okay, these are Mulliken symbols. Okay, say, okay, so three means t. Okay, three means t. Three means t. Okay, uh, then the second rule. Okay, so if both contains a, you all Mulliken symbol should be different. Okay, so if all contains one, how should you differentiate the four irreducible representation? So you should see the principal axis. Okay, principal axis, if you it contains principal axis plus one means a, it principal axis is anti-symmetric means minus one means b. Okay, you see the plus ones are designated as a and minus ones are designated as b. Okay, and another rule is, so if the principal axis also same 1 1 1. Okay, principal axis 1 1, then how did you differentiate these two Mullikens? Then see the other C2s. Okay, perpendicular C2, C2 perpendicular to NC2 because it is a D4 height, so C2 perpendicular C2. Okay, if C2 is absent, perpendicular C2 is absent means it is C group. You see the vertical plane sigma v. Okay, it is plus one means a1, minus one means a2. Plus one means a1, minus one means a2. Okay, so that you can differentiate a1 from a2. I think this is all know. Okay, center of symmetry. Center of symmetry is plus one means gerade. Okay, and the center of symmetry is minus one means plus one means gerade, minus one means ungerade. Okay, means uneven. Okay, gerade means even. Okay, um, so this prime, this is also important. If it contains say, sigma h is same, so it contains 2e, so you differentiate the 2e from sigma h. Sigma h is plus 1 means prime, sigma h is minus 1 means double prime. Okay, there is easier question about these questions. Okay, and the most important concept is the stretching vibration. The most of the Caesar questions are come from the what IR active modes, Raman active modes, like that. Okay, so you should know the basic concepts. So in the IR active and Raman active, so you should see the atoms. Okay, so atoms unchanged or unchanged atoms. Okay, you should see the unchanged atoms. Okay. Simple sketching, you should see as a vector. Okay, suppose only interested in sketching modes, not at all vibrational modes. The reasonable basic set is two vectors. Okay, so if it is vibrationals means you should see the unchanged atoms. Okay, you do the all symmetry elements and see how many atoms are unchanged. Okay, this is CTV point group. First element is identity. Okay, this is for sketching. Okay, so this is for sketching. Okay, simple sketching. I tell the examples for vibration C2 sigma v and sigma v dash. Okay, so if you do the identity means the molecule is unchanged, otherwise 360-degree rotation, so both leave the molecule unchanged. Okay, so then okay, so number of unchanged atom is 3. Okay, so if you perform a C2 axis, the oxygen atom only unchanged, the hydrogen change their place. Okay, number of unchanged atom is 1. Okay, the sigma v is if you take sigma v is molecular plane, so this is molecular plane. Okay, the number of unchanged atom is 3, and if you take the sigma v prime, this is the sigma v prime. Okay, cut the k into twice. Okay, so number of unchanged atom is 1. Okay, so these each symmetry element as a character. So first number of unchanged atom for higher active and Raman active, find the rules are first you should find the a number of unchanged atom. Uh, Draw the molecule and put all the atoms. Okay, so don't miss like that. Some other example, pyridine also in one example they give pyridine. Okay, so you should mention all the hydrogen. Okay, all the hydrogen. These also pyridine also CTV point group. Okay, so it should mention all the point group. Identity means 6 6 6 12. Okay, 12. So this is number of unchanged atom. Then character per then there is another term is included. This is character. Okay, so the that means identity always give the value of 3 and I also gives the value of 3 and cn if you cn means the formula, there is a formula 1 plus 2 cos theta. Okay, and Sn there is there is also form if you substitute the formula, you see you can find this formula in books. Okay, so I just not forget to mention. C2 means -1. Okay, all sigmas are contains 1. Okay, value 1. So if you both multiply these values, you get a value that is reducible representation. And there you should know the reducing formula. Okay, the reducing formula is 1/4 like that. Okay, so okay, I see the I tell you in separate example. Okay, so these are translations xyz and rx ry are rotational. um, so okay, I will tell you examples. Okay, how to do the IR active and Raman active. Okay, where is this? Open report. Okay. Okay, first you should draw the molecule. Okay, so I take the example simple. You should practice with other molecules also. You can familiar with it. First you should find the point group molecule. Okay, so this contains C2 rotational and sigma V. Okay, there is no perpendicular C2, so it does not contain to the DN point group. So it is simply C2V. Okay, the point group is C2V. You find, then you find the symmetry element present. Okay, E C2 sigma V prime. Okay, these are the 4 symmetry elements. Okay, then perform the symmetry element to this molecule and find the unchanged atoms. Okay, first identity means identity C2 sigma V prime. Okay, number of unchanged atoms. Okay, number of unchanged atoms is number of unchanged atom is 3. Okay, C2 number of unchanged atom 1. Sigma V number of unchanged. It takes sigma V is molecular plane. Okay, molecular plane. Sigma V dash 1. Okay, so I already the character for identity 3 for C2 -1 sigma 1. Okay, you multiply 3 into 3 9, 1 into 1 -1, 3 into 1 1, 3 and 1 into 1. Okay, multiply you get 9 -1 3 1, right? 3 1. Okay, so 3 into 3 9, 1 into -1 1, -1, 3 into 1 1, 1 into 1 1. Okay, so these are the reducible so sometimes they give the reducible representation. Okay, then the reducing formula is simple. this is number of irreducible representation. So if you first see number of A1s, okay, you see the group see C2A point group, A1, A2, B1, B2, okay. Mulliken symbols are A1, A2 and B1, B2, okay. So first number of A1, so formula is simple, 1 by H, okay. H is the order of the point group. C2 is the point group order is 4, okay. Then you should multiply the characters in the class, okay, and in the irreducible representation and the reducible representation, okay. So here we take the example 9 into 9 into, and the class A1 contains one element only, okay. So if you take the C3 point groups, the C3 contains 2 C3, okay. But here A1 is 1, okay. So 1 into the character in the they many times they give the character table, but it should be better to familiar with the C2V, C3V point group, okay. So sometimes they don't give this point group because everyone know this point group, so sometimes they skip it. Most of the time they give the point group character table, okay. 9 into 1 into 1, okay, plus, so you should multiply minus 1 into minus 1 into 1 into 1, okay, like that. 3 into 1 into 1, like that. 3 into plus 3 into 1 into 1, like that, plus 1 into 1 into 1. So you should multiply all this, you get 1 by 4, 9 minus 1 plus 3 plus 1, okay. So you get 9 plus 3 12, okay. So 3 A1s, okay. So there are 3 A1. A1 is irreducible representation. Reducible representation means it can further reduce. Irreducible representation means it cannot further reduce, okay. um, so I don't go with the high level, okay. So this is the formula, okay. So from that you can find number of A1, like that. Same the formula, uh, you go with the number of A2s, one by order, and one by order, and this reducible representation, and the class, the number means the number, the nearby the class symmetry element, okay. So you should multiply these three numbers, okay. These three numbers you get number of A1, number of A2, number of A1, A3, like that, okay. So if you find this, so I will go with the PPT. This is if you find each steps, you find this. We find three A1s. You apply the same formula to A2, B1, and B2. You get this. So then you should and these are total allowed transition by symmetry, okay. And three are translations. I say the X, Y, I, Z are translational, and three rotational, okay. And the RX, RY, RZ are rotational, okay. So you see the translation in the Z axis, translation in the X axis, translation in Y axis, rotational in Rx, Ry, Rz, okay. You should minus these to get the vibrational only, okay. So Ram and IR are vibrational, so you should minus these rotational and translational to get the vibrational, okay. You should minus from this total irreducible representation. Okay, so total, if you minus the translation and rotational, you find the vibrational. Okay, simply minus it. It the 1a1 minus, you get the 2a1, a2 minus, so 0, 2b1 there, translation 1b1, rotation 1b1 minus cancelled. 3b2 are there, 1b2 and 2b2 minus, also 1b2. Okay? So 2a1 plus b2 is vibrational. From that, you should differentiate from IR and Raman. Okay? So if molecules contains center of inversion, it follows the mutual exclusion principle. Means the IR active modes are Raman inactive, and Raman active modes are IR inactive. Okay, the molecule contains the center of symmetry should obey the mutual exclusion principle. This H2 is not, it does not contain the center of inversion, so it does not obey the mutual exclusion principle. Okay. So both are same. Okay, so IR active modes are Raman active, Raman active modes are IR active. Okay, so how to find Raman and IR active? Okay, so the X, Z, Y. So these are, if you find A1 and B1 and B2, these are IR active. Okay, so the translations are IR active, and the other X, Y, X, Z, these is are Raman. Okay, so the XYZ are IR, and X square, Y square, Z square, and these symmetry elements are Raman. Okay. Okay. Here they give. Okay. The YB2 is Raman active, IR active, blue color. They circled with blue color. Okay. So Y is blue, and Z A1, that is IR active, and they circled the YZ and X square, Y square minus. These are Raman active. Okay. So first you should draw the structure and find the first number of unshifted atom, then the character per atom, then you should find the reducible representation. From reducible representation, using the reducing formula, you should find number of A1s, number of A2, number of A1, B2. From that, you should minus the translation and rotational. You get the total vibrational. From vibrationals, what are Raman and IR active, you should see the XYZ. XYZs are IR, and the X square, X square, Y square, Z square, like that. These are Raman active. Okay. The concept is IR active mode should be, the vibration should be change in dipole moment, and Raman active, there is change in polarizability. Okay, you should know the difference between these. Okay, so many of the time you should confuse with the Raman active, polarizability and dipole moment, like that. Okay, so if you see the CO2 molecule, if both symmetric sketching means the both O are sketched same distance, so the dipole moment here is not changed. Okay, so because both O are samely electron withdrawing group, they go same distance. Okay, from carbon, so there is no change in the dipole moment. So this symmetric sketching IR inactive. Okay, so CO2 is a center of molecule, so it molecule with center of inversion. Okay, so it obey the mutual exclusion principle. So it is IR inactive. So but it is Raman active. Raman polarizability is like the water in your bottle. Okay, so if you the water, the can is full of water, you cannot shake it. Okay, so if you that is means you cannot polarize it. Okay, so if water is if the water bottle is half filled, you can polarize it. If you shake the water moves from that side to that side. You can, this is the polarizability. Means the real concept is, if you the electron cloud, how to polarize from the electric field applied, how much it polarize it. Okay, how much it distort the electron cloud. Okay, that is the polarizability. You can imagine like that, a balloon. Okay, balloon. So if you stretch a balloon, the it scratch it. Okay, so like that. um, so dipole moment is not like that. It is like uh, a row, two opposite groups are pulling the row, pulling a rope in opposite direction, that is the dipole moment. The more active negative element easily pull it, okay. But the less electronegative element cannot pull it, so the distance between them is decided. So here the most electronegative oxygen is same distance between though, so there is no difference in the pulling, okay. So dipole moment does not change. But if you consider a balloon, water balloon like that, if you pull it, the cloud, electron cloud, is slightly distorts, okay. So the carbon oxygen distance is changed, okay. So they, so that more easily polarizable, okay. So it becomes more polarizable when there is the nucleus are close together, electrons are interact with the nucleus, so that it cannot easily polarize. So if you separate the oxygen from the carbon long and long, it become more polarizable, easily polarizable. The electron become unstable and easily polarizable. So this is Raman active. So like that. So you should familiar with this. So don't confuse with the IR and Raman actives. Okay. So I don't go with the step by step. So I mainly pointed out the where you make mistakes and how to rectify that. Okay. So that's why I tell these concepts. Okay, this is how they put z, x, and y, and in A1, B1, or B2. So simply this. So z axis is simply put an arrow into z and do the all symmetry element. E means unchanged. C2 z means unchanged. Sigma xz means the arrow does not change. Yz means the arrow does not change. Okay. So that's why this is totally symmetric. Okay. So if you just put arrow in y axis, so if you do the C2, it means C2 rotation, the direction of the arrow is changed. Okay. So where is the y? Here. Here you get the y. Okay. So the C2 is -1. Okay. Just like that. If you do mirror plane in XZ, the y will be also changed. XZ mirror plane means the arrow of y changed. So -1. Okay. Like that, y is that there is no change in the direction of y, okay. So unchanged +1, okay. um, from doing this only they put to the x y z in the group table. So I already told this mathematics, so they already do all calculations and simplify in a table like multiplication table or formulas like that. So you should know how they come from, okay. Then only when questions asked you should able to understand what they asked and how to answer it, okay. So you does not understand these concept, you cannot answer the questions, okay. Okay, you can also use the permanent dipole moment from the group theory, okay. If a molecule contains cannot polar if molecule center of inversion, means center of inversion means um, uh, from the center point from equal distance you find equal atom, that is the center of inversion, okay. uh, so it cannot be polar, okay. So same atoms is it should be, the atom should be same, okay. So same electronegative element like that. So there is no dipole moment. Polarity, so there is no polarity, okay. Dipole moment cannot be perpendicular to mirror plane, okay, like that. So they cancel out like that. CO2, we see the example CO2. If you do a mirror plane here, the electron withdrawing by this O is equalized by this O, okay. So there is no dipole moment, okay. The dipole moment of CO2 is 0, okay. Like that dipole moment cannot be perpendicular to CN axis, okay. Okay, chirality you all know, improper rotational. If a molecule contains improper rotational, it cannot be chiral, okay. So these some of the examples, chiral examples. So molecular orbital, so I does not go with this. When inorganic comes, we see these topics, okay. I think time is over. Okay, we see the remaining in the next class. Okay, I think time will be